Check out the nice clean boards, folks. Aren't they lovely? Okay. Problem number 1. Now, you have all studied exponents before. We are going to go through them very, very carefully so that you remember all of the rules that you learned before. Problem number 1. We need to talk about this. What in the world does a 1/2 exponent mean? Does anybody remember? No. What? Square root. A 1/2 exponent means square root. Any fractional exponent means a radical. Fractional exponents mean radicals. The denominator of the fraction tells you which root you are taking. So here is a fractional exponent. That means it's a radical. I'm doing a radical in this problem. The denominator of the fraction tells me which root it is, like a cube root, 4th root, 5th root. This is a 2, so it's a square root. I'm taking the square root of 16x squared. What's the square root of 16? 4. What's the square root of x squared? X. There's the answer to the problem. Fractional exponents mean radicals. Every time you see a fractional exponent, you're going to think radical. Let's look at the next one. This one has an additional complication. There's a fractional exponent. I'm going to handle that. Who remembers what a negative exponent means? What? Yes. So instead of having 9, we're going to have 1/9. When you have a negative exponent, it moves the numbers around. It flips the fraction. So if you think of the original problem as being 9/1, then it's going to flip, like Will said, and become 1/9 to the 3/2 power. When you flip it, the exponent then becomes positive. Now, we're going to practice some more. Try to stay with me.
That's the answer.
No. A fraction means a radical. The denominator of the fraction tells me which root I'm taking. So I'm taking the square root. The 3 tells me I'm going to cube it after I do the square root. So I'm going to take the square root of 1/9. Anybody know what that is? The square root of 1/9 is 1/3. And I'm going to cube that. The denominator tells me to take the square root. The numerator tells me then to cube the answer that I get. So 1/3 cubed would be, not 1/9, 1/27. Because what does cubing mean? Multiplying 3 times? So 3 times 3 times 3 would be 27. Okay? Number 3. No fraction. Thank goodness. What does that mean? There's no fraction, so there will be no, Suzanne?
Squaring.
No fraction means there will be
No squaring.
no square root, no radical. However, there is a negative. That means it's going to go to the denominator, right? So we're going to rewrite this as 2 over x to the 5th. Now, I will put this question on the test. I put it on every test because there are kids who won't pay attention, and they'll say 1 over 2x to the 5th. Can anybody tell me why this is the wrong answer?
Because the negative 5 exponents connect to the f.
Exactly, Gibran. I could not have said that better myself. The negative 5 is hooked to the x only. Okay? It is not affiliated with the 2 at all. So the 2 stays where it's at. It doesn't get flipped. The 2 doesn't get flipped. Only the 5, or the x does. Only the x does. So this is the correct answer. Now, look at the next one. Tell me what's different about that one.
It's connected to both.
It's connected to both. So when I take care of this, I'm going to put 1 over the whole shebang. Because the negative 3 is hooked to both of these. Negative exponents mean the whatever it is, in this case the 3x, goes to a different place. So if it's already in the numerator, it's going to go to the denominator. So we have 1 over this. Now let's finish it. What does 3x cubed, 3x quantity cubed, what does that equal? 27x cubed. Why is that in the denominator again? Because it has a negative exponent. When things have negative exponents, they go to the denominator. Now, we're going to spend a little more time on this, but before I do, I want to look at the rest of the homework, which was in your book, and make sure that we have that under control. Okay, then we're going to go to our note sheet. But first, we're looking at the rest of our homework here, which was the quick review. Some radical practice.
Which one? Bradley went in Alabama. Bradley went for Alabama. Did you get it done?
Okay.
I think they're just on their emails. Maybe. I don't think they take it off. Yeah.
Okay, kids, here we go.
There's so many kids that probably just can't keep up.
Too many wires. Okay, what does this mean? No, there won't be an I. This is a trick problem. I's only happen when we take the square roots of a negative. Okay? I's only happen when we take the square roots of a negative. This is the cube root of a negative.
Trickery.
Uh-huh. Does anybody know what the cube root of 216 is?
Would it be like 216? That's 13?
Well, you can check it. Take your calculator out and do 13 times 13 times 13. Ron, I think that's a little bit big.
6.
Yeah, that's 2,197.
Okay.
6. Ethan Topham says 6. Let's see. 6 times 6 times 6. 216.
777.
So the answer would be -6. Because if you multiply -6 times -6 times -6, will you get -216? Yep. Yep. The cube root of a negative is a negative. The square root of a negative is an I. The cube root of a negative is a negative. The square root of a negative is an I. Good. Okay, how about this one? The cube root of 125 over 8. Do you know how to do the cube root of a fraction? What's your common sense tell you?
Divided by 3.
Not divided by 3. We want to take the cube root. What's the cube root of 8? We all know that. What's the cube root of 8? 2. Anybody know the cube root of 125? 5. When I take the cube root of a fraction, groupies, I just take the cube root of the top and the cube root of the bottom individually. So the cube root of 125 is 5 and the cube root of 8 is 2. The answer is 5/2. Oh, whoa, 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 whoa. Fractional exponent. Oh, I erased it. What does a fractional exponent mean? A radical. And the denominator tells me which radical. So this is going to be a cube root problem. The denominator tells me which root I've got. So this is a cube root problem. And I'm going to get my answer, and then I'm going to square it, because that's what the power tells me to do. One more time. This says cube root of 27. This says, whatever you get, square it. What's the cube root of 27? 3. 3 squared is? The answer to the problem is 9. The cube root of 27 is 3. That means 3 times 3 times 3 is 27. Squared would be 9. All right, this is the same exact problem, kind of problem. Do you see this fraction? Taylor Holder, you see this fraction? That's screaming, radical, radical, radical. So I got a radical here. What does that 2 tell me? It's a square root problem. The denominator tells me which root. So I'm going to take the square root of 4. What's the square root of 4? 2. What am I going to do with that 2? I'm going to take it to the 5th power. 2 times 2 times 2 times 2 times 2. What is that? 32. Very good. These are your properties of exponents. Do you remember when you have back-to-back exponents? You multiply them. Very good. So that's going to be 2 to the negative 12. Wait a minute, wait a minute. What do negative exponents mean? Flip it. So instead of being 2, this is going to be 1/2 to the 12th. Now that's a huge number. I'm not going to make you do that. So you can just leave it 1/2 to the 12th. Why is it 1/2? Because the exponent was negative. And what happens when you have a negative exponent? You go to the denominator. When you have a negative exponent, you go to the denominator. What will this be? Step 1. A to the negative 6. Back-to-back exponents get multiplied. What does that mean? Flip it. So what am I going to have? 1 over A to the 6th. Which, by the way, if you prefer to write it like this, that is totally fine. It is the same thing. To the negative 8. Great first step. Back-to-back exponents multiply. 3 to the negative 8.
1/3 to the
1/3 to the 8th or 1/3 to the 8th, whichever you like best. They are the same. It makes no difference. Whoa, how about this one? That's going to be b to the 15th, and that's it. We're done. That's a positive exponent. That's not going anywhere. That's it. All right, let's take a look at our note sheet now. That takes care of your homework. Now we're looking at our note sheets.
Did you get that, my mom did?
Yeah.
I always get that color when I go. It matches everything. So I can better. I just took this one off and then I broke it up out of it. Not kidding.
We're going to be doing a lot more simplifying of exponents. But we've got some ground rules to set here first, some vocabulary. So we're going to start with that. So everybody's on this packet of note sheets, problem number 20, or page number 24. Here we go. We've taken a lot of notes. We're on page 24. Here we go. Let's read the directions. Which are exponential functions? If they are exponential, state if they are growth or decay, state the rate of growth and decay, and state the initial value. Now, you're thinking, oh my gosh, what's she talking about? But these are really easy. First of all, an exponential function has to fit this pattern. So an example of an exponential function would be y equals 3 times 4 to the x. Or y equals 0.2 times 8 to the x. Or y equals 5 times 0.3 to the x. Those are exponential functions. So when I look at problem A, does it fit the pattern of y equals something times something to the x? It does. So A is exponential. Now, this number, look where I'm pointing, not the one with the x, the other one. This is the initial value. So one of the questions is, for problem A, state the initial value. So you will say the initial value is 3. Okay, easy. Now, I want you to just think about this, using your head for a minute. If I keep multiplying by 1.23, because that's what this equation is telling me to do. It's saying, okay, the first time it would be times 1.23 to the first. Then it would be times 1.23 to the second. Then it would be times 1.23 to the third, and so on. We just keep letting x get bigger and bigger and bigger. Will these answers get bigger or smaller? Bigger. Why are they getting bigger? Because you're multiplying by a number bigger than 1. If you multiply by 1, things stay the same, right? But if you multiply by something bigger than 1, they get bigger. So is this a growth problem or a decay problem? Growth. If you're getting bigger, you're growing. How do we know whether it's growth or decay? We look at this number, the one hooked to the x. If the one hooked to the x is bigger than 1, it's a growth problem. If the one hooked to the x is less than 1, it is a decay problem. Got it? Now, what does it say? What is the rate of growth or decay? All right, now listen. How do you know it's growth? It's bigger than 1. Your rate of growth is how much bigger than 1 it is. So how much bigger than 1 is this number? 0.23. So you will say 23% growth. however much bigger than 1 it is, that is your rate of growth. So for problem A, it's 23% growth. It's growth because it's bigger than 1. It's 23% because that's how much bigger than 1 it is. Got it? Okay, let's look at problem 2. Step 1. Does it fit this pattern?
Yeah.
Is it something times something to the x? Yes. What is its initial value? 1/2. Growth or decay? Decay. How come it's decay? Because 0.83 is less than 1. How much less than 1 is it? 17%. So this is a 17% decay. If you can't do that in your head, you would type into your calculator 1 minus 0.83, and that would tell you that it's a 17%. You get 0.17, that's a 17% decay.
So the answer is 17%.
Decay. Kaylin, they're not even close to the same thing, sweetie. Okay. All right, C. Problem C. Is it exponential? No, it is not. Kids, look at your exponent. What is your exponent supposed to be in an exponential? X. Is your exponent an X in problem C? No. Not exponential, move on. D. Is it a number times a number to the x? D. Yes. What is your initial value? 100. Would you say growth or decay?
Growth.
Growth. What is your rate of growth? 2% growth. How do I know it's 2%? Because it's 0.02 bigger than 1. Remember, your rate of growth or your rate of decay is how much bigger than 1 you are or how much less than 1 you are. E. Freakish. Absolute freak problem. No, it is not exponential, because to be exponential, you have to have a number times a number to the x. We don't. So 4 or 5, whatever, I'm on D, E, E. E is not exponential. How about F?
Yeah. 8%. Yes.
F is exponential. What is my initial value?
8% growth.
3.6. Would you say growth or decay? Decay, because 0.92 is less than 1. How much less than 1? 8%. This is an 8% decay problem. Are you still with me? Okay. Now number 2. We are going to write our own exponential function. I know, isn't it exciting? I want you to start by writing this down. So you got space down there. I want you to write this down. This is what you're shooting for. Now, they have given you 2 points. One of them has a 0. Jared, I always want to start with the number that or the point that has a 0. So I am going to take the point 0, 2, I'm going to remember that this is the x and this is the y, and I'm going to plug that point into my equation. So what will it look like? 2 equals a times b to the 0th. I'm taking the point that has a 0. They gave you 2 points. Take the one, start with the one that has a 0. Start with this point. This is the x, this is the y. Plug those into your equation for x and y. Now, who can remember what b to the 0th is? If you've forgotten, make a note somewhere. Anything to the 0 power is 1. When you raise a number to the 0 power, you will always get 1. It doesn't matter what the number is. So when I have in my equation now, I have b to the 0th. B to the 0th is 1. So what does this really say then? If that's just 1, this says a equals 2? Huh?
Put the 1.
Well, 2 times 1. What's 2 times 1? 2. So we don't normally. It would be wrong. We don't normally put that. A is 2. So now let's go back and look at our equation. Now we have y equals 2 times b to the x. Because you know that the a is 2.
Oh, I see what you're gonna do.
Now you know what I'm going to do next. Because what else did they give me? Another point. So now I'm going to take the point 1 comma 6, and guess what I'm going to do with it?
2 equals.
I'm going to plug 6 in for the y and 1 in for the x. How are you going to solve that? 2b equals 6, which means b equals 3. And what's my equation then? Y equals 2 times 3 to the x. Now, do not ever multiply these together. Don't be giving me 6. No, no, no. These are separate numbers. A times b to the x. Okay, let's see if we can remember how to do this now. We're doing another one.
You're going to start with 0 and 1.
We'll start with the 0 point. So first, Katie, I'm actually going to start by writing down my equation. This is my exponential equation. And then, like Katie said, you've got 2 points. That's all you're given is 2 points. Use the one that has the 0 first. So the point with the 0 is 0 1/2. What's this? X, Y, put them in. So we'll have 1/2 equals a times b to the 0.
Which equals?
B to the 0th is just 1. So a will equal 1/2. So y equals 1/2 times b to the x. Because now I know a is 1/2. Because b to the 0th is 1. It like cancels away. Now what am I going to do next? I'm almost done. I'm half done. Plug in the other point, which is 2 comma 8. Now I know this sounds dorky, but kids, be careful. When you plug in your point, what do you do with the 2? Where does the 2 go? X, and 8 goes in for y. So 8 equals 1/2 b to the second times both sides by 2. So 16 equals b squared. And b equals 4. Now, what's the answer then?
Y equals 1/2 times 4 to the x.
Perfect. Y equals 1/2 times 4 to the x. Do not do anything with these. They are two separate numbers. Leave them separate, Megan. Always. It's the initial value. It will always turn out. Megan has made an observation. She says, Miss Ford, I really want to do all this work here. Look, in the first problem, A turned out to be 2. In the second problem, A turned out to be 1/2. Will that always work? Yep. Always. This number in your 0 point, that will always be your A. When you solve it, you'll always get that for A. So when I look at the next one, 6 will be A. Yeah, problem C, 6 will be A. Now, I do not want that to confuse you. That's Megan's observation. She's dead on. It's exactly right. But I don't want that to confuse you. So if you want to work it out like we've been doing, that's fine. But indeed, for problem C, A will be 6. So if we go with that A will be 6, then we have the equation y equals 6 times b to the x. Now where do I go from here? I got to plug in the other point. Oh Lord, it's got fractions. 4 comma 3/8. Okay, let's be calm. 3/8 equals 6 times b to the 4th. Now what do I need to do first? I need to divide by 6. I need to get rid of that 6. I need to divide by 6. But since there's a fraction over here, what else could I do besides dividing by 6? Multiply by 1/6. Would that accomplish the same thing? So these are gone. Now what do I have over here? 3/48. Does 3/48 reduce? So 1/16 equals b to the 4th. I'm going to 4th root both sides. So b equals the 4th root of 1/16. 1/2. You guys are good. How do I know the 4th root of 1/16 is 1/2? Because I know that 2 times 2 times 2 times 2 is 16. I expect you to know that too. I know it's probably unreasonable of me in math. We should know that the 4th root of 16 is 2. So what's our final answer then? You are exactly right, Olivia. Y equals 6 times 1/2 to the x. You gonna put these two together? No, never. one more of these guys, and you get to practice some in your homework tonight. Step 1. The point is 0, 10. What's step 1 going to be? 10b to the x? Now here comes the fun part. 80/27 equals 10 times b to the third? Now you can do this. We just did one, so let's go back through those same steps. What do I have to do first? I got to multiply by 1/10. I divide by 10 or multiply by 1/10. So b to the third will equal 80 over 270. Remember when you multiply fractions, top times top, bottom times bottom? Now how about 80 over 270? Does that reduce? Yeah. Can't you cancel those out? So you have 8/27 equals b cubed. Exactly. Don't we need to cube root both sides, you guys? Cube root both sides. What's a cube root of 8? 2. What's a cube root of 27? 3. So your answer is y equals 10 times 2/3 to the x power. Those problems look scarier than they are. Oh, don't pack up. We're not done. Now we got part 3, which looks familiar to you. What does a fractional exponent mean? I'm looking at problem 3A. It means a root, a radical. Since this is a 1/3 power, what root am I taking? The cubed root, the third root. What is the cube root of 8? 2. The answer to problem A is 2. Because the 1/3 is a fractional exponent. Fractional exponents mean radicals. And the denominator tells me which radical. So this is a cube root problem, a third root problem. How about B? It's also 2. The answer is also 2, because what's going on here? What's going on here? The fourth root of 16. That's 2.
The next one.
Oh, but we have to have 2 at the end.
If you do 2 like that.
16 is 2 times 2 times 2 times 2. There's 4 of them. So no. So when you take the 4 through to 16, you get 2. The answer is 2.
So wait, when I get yours,
What's the cube root of 8? 2. But then you have to square it, so the answer would be 4. So Katie has already done problem C. Let's look at problem C. Javon, I need you paying attention. This is going to be a quizzy-poo question in the very near future.
I got the answer.
8 to the 2/3
It's 4.
means the cube root of 8, because the denominator tells you which radical. So it means the cube root of 8 squared. What's the cube root of 8? 2 squared. 4. There you go. Have a good day.